Good morning, everyone, to MSc second year students of Department of Physics. This is Vamsa Krishna, Department of Physics, AKNU Rajahmundry. So today we are going to discuss about n elements linear array. As I told you that linear array can be formed by the antennas are arranged in a in a single line, means in one dimensional. If we arrange the atom means antennas in a one dimension, then it is form the linear antenna array. So if it is n, if there n antennas are arranged in a one dimension, then it is n elements linear antenna array. Okay, sorry. And an array of n elements is said to be linear array if all individual elements are spaced equally along the line. So there is a one condition that antennas, whatever the antennas arranged in a one dimension, there should be an equally spaced. Okay, the antenna is said to be uniform array. When we the antenna array is said to be the uniform array, if the antenna elements in the array are fed with current with equal magnitude with uniform progressive phase shift along the line. So when we say the antenna array is uniform array, when we say that is whatever the antennas are fed with the current, that should be equal in magnitude and phase. So consider a general n element lines and uniform array with all individual elements are equally spaced at a distance d from each other. So as like these are the two A1 and A2 is the two antennas are arranged in a linear form. Now we are discussing about n antennas are arranged in a linear form. Okay, so that same way, same diagram with the n lines. The total resultant field at a distance p. So here also we are going to find out the total electric field at a point p from the respective radiation from the respective antennas. So we are going to find out the electric field at a point p from the respective antennas A1, A2 up to so on AN. Okay, so we have considered for first antenna is A0, the next one is A1 up to so on AN-1 antennas. So what are the electric field produced from the from the A0 antenna is E0 into e power of minus j into 0 plus electric field produced from the antenna antenna A1, which is equal to E0 into e power of j psi means phase angle, plus E0 plus j E0 power E0 into e power 2j psi, which is equal to, that's the electric field produced from the antenna A2. Like that, the nth antenna will be equal to E0 is equal to e power j n minus 1 psi, which represents the electric field at a point P from the antenna, nth antenna. If we sum up all the electric fields at a point P from the all antennas, then it is equal to E naught of 1 plus e power of j psi plus 2 plus e power of exponential of 2j psi up to so on exponential of j power j n minus 1 psi. So note that previously in yesterday class we've this phase shift which is equal to beta d cos phi. So same like that we note that psi is equal to beta d cos phi plus alpha. This is alpha, indicates the total phase difference of the fields from the adjacent sides calculated at the point P. Alpha be the phase shift between the two adjacent point sources. Alpha be the phase shift between the two adjacent pakkana unna point sources. Point sources means antennas whose values lies between the 0 to 180 degrees. If alpha is equal to 0, then we get n element uniform linear broadside array. If alpha is equal to 80, we'll get linear end fire array. So multiply the equation 1, okay? Multiply equation 1 by e power of j psi. E power of j psi. Then equation 1 becomes e power of j psi into et, which is equal to e naught times of e power of j plus e power of 2j up to so on e power of j n psi. So now subtract 2 from 1, then you will get this expression. Okay, so take it out now. Take it out e power of j n psi by 2 from the numerator. Take it out e power of j omega psi by 2 in the denominator. So I will write it 1 minus e power of j n psi by 2, 1 minus e power of j psi. It is there like that, right? So take it out this is j n pi psi by 2. Okay, this is e power of minus j n, sorry, not n, so you can take it out e power of minus j n psi by 2 from the numerator. So then equation will become like this, sorry, plus 1 plus j, then minus j n psi by 2 minus e power of j n psi by 2 divided by e power of j psi by 2 divided by e power of minus j psi by 2 minus e power of j psi by 2. So now this expressions is like the sine of n psi by 2. This is sine of n, not sine of psi by 2. Okay. So so e power of minus I theta minus e power of I theta is equal to minus 2i sin theta. Then equation will become like total electric field at a point P from all the point sources. Et is equal to E naught in E naught times of sin n psi by 2 divided by sin psi by 2 into e power of j n minus 1 into psi by 2. So this equation represents the resultant electric field at a point P to the n elements array. Resultant field Et to the n element array at P. The magnitude of resultant field is this one. So this is the magnitude. The phase angle theta of the resultant field at a point P is equal to n minus 1 by 2 psi. Substitute the value of psi in the above expression. Okay, thank you. So next in next class I will explain the multiplication of patterns.